Alrighty, wasabi, you guys. We're about to try out the finals problems from Caltech math meets. So, this is their integration B, and these are the. This is the slide for their integration B finals. So we're about to try these integrals and see how far or how many I can solve. Okay. Alright. If you haven't seen last year's, definitely check that one out, because I struggled a lot, especially with like piecewise functions. But here, let's see if they've gotten harder or easier or in between. Alright, let's start in with the first problem. Easy. Okay, this is what they claim. They claim these integrals easy. Let's see. Oh, would you like? Oh, okay. It's not that bad. So here, we can see that this is just, oops. So we know that we're definitely going to let u equal tangent of x, right? So what we have here is we had something like this, right? I think that's what it was. Yes. So now here, you would just let Heaviside method, because we know this is like u plus 1. Oh, I'm sorry, no. U minus 1. U minus 1, u minus 2. Okay. Here, actually, there's, notice that they're off by 1 increment. Okay? They are off by 1 increment. So what we're gonna do is we're gonna go like this. We're gonna go like u minus 1 minus u minus 2. Because what this is, wait, that does equal, right? That should equal. Yeah, this equals to 1. Yeah, so we're gonna go like this. So if they're 1 increment off, you can go like this. Okay, and so now it's just easier for you to see, oh, this is u minus 2 minus 1 over u minus 1. Okay, and then you can go ahead and dive in like that. So our answer, you can even put it together if you want it to go faster. Save some time before your opponent reaches the answer. Okay? So that would be my answer. And let's see what they said. Yeah! Okay, so if it's like 1 increment off, oh crap, if it's 1 increment off, you can just go like this. Just go like this. Okay? Be very careful. If it's like negatives, like you just have to be very careful. Just kind of check, make sure that you didn't flip any negatives or anything. Okay. We have this. We already know immediately what to do, right? You let u equal 1 over x, right? I'm sorry, u equal 1 over x. Yeah, u equal 1 over x. For some reason, I thought I said u equal x. I'm like, what? But you end up with just sine of u. And I saw it was like pi over 2 here. And infinity. Oh, okay, I see what they're doing. 0. And then this is equal to like negative cosine of u. 0 pi over 2. What am I doing? You could just use Wally's product. I mean, Wally's trick and just answer 1. Yeah, that would just be, I don't know why I did this, but in Wally's trick, that's just equal to 1. Okay, so we should have answer as 1. Yep, there we go. Alright, cool. Next. Oh, you already know what this is. if you could just kind of do this in your head, technically, right? If you let u equal ln of x, you get u ln of x. I'm sorry, u ln of u, and then ln of, yeah, so pretty much the answer is just ln of x. You should get ln of x. Oh. I forgot. Okay, maybe sometimes it's best when you don't do it mentally, but to double check, so we let u equal ln of x, and then you get 1 over u, and then you get ln of x. Okay? I'm just being lazy. Don't be lazy. When you actually compete, don't be lazy like me. Okay. Oh, this. Okay, when you see something like this, this is a very famous, a very reoccurring integral that you're gonna see so many times, is you're gonna see this a lot. Okay? You're gonna see this a lot if you compete at a lot of integration bees, or like mock integration bees, or other past exams. But what we have is an inverse cosine, and it does the exact same procedure. Okay, I'm going to bring in the negative with cosine inverse, because so that I don't mix up myself. This is going to equal to this, and integrate, and then here we get 1 minus x squared. The negative cancels out. Oh, wait. No, it doesn't. No, it doesn't. Because inverse cosine, the derivative of inverse cosine is a negative version. And so it's going to be, and then with negative, it cancels out, but then I have the negative from integration by parts. So what we have is x plus 1 minus x squared inverse cosine of x plus c. So this is what we should have. And if we check, that's exactly what we got. Okay? So whenever you see something like this, integrate this whole thing. Integrate this whole thing, and then if you do this a lot of times, you'll start to mentally know the answer to this. Okay? You just have to integrate a lot with that integral. Alright, next. I'm not surprised. Okay, so 1 over 2e. 1 over 2e of ln of x being floored. Okay, so when we plug in from 1 to e, we get 0, right? So from e to 2e, it's just going to equal to 1, because it'll only reach to 2 when it's like e squared, right? This is definitely not e squared, this is 2e. So our answer should just be e. So our answer is like 2e minus e. So I think the answer should be e. Is the answer e? I'd be mad if it's not. Okay, cool. Alright, well there you go. So our first piecewise integral where we have to manually integrate and split the bounds. Alright, next one. Of course. Huh. I wonder what it could be. Interesting. So, it seems like this is pi over 4 times square root of 20. Oh, no. Wait. Pi over 4. 2024. Yeah. So, I guess 5. So, it'll be 506 pi. 506 pi? Yes. This is an area of a partial circle. So, it's very suspicious, the fact that it looks like this, right? Especially this. This was extremely suspicious. Like, why would they put this, right? So that's like a way of thinking. For every integral in integration B, it's like, what is the purpose of this integral? And this, the whole purpose is that you use area of a partial circle. Okay? So let's go ahead. Okay, don't freak out. Don't freak out. Do not get problem shock. Do not freak out. What do you notice? Oh, the bounce. What is this? It's 0. 0. Yeah. I really hope that you answered 0 before your opponent does. Okay? It's extremely important that you do not get problem shock. Okay? I might have to make a separate video on like practicing problem shock integrals so that we get used to not getting problem shock. But yeah, do not get problem shock. This is of odd function. Okay. All right, 0. Nice. Okay. So this is x. This is secant x tangent x, as you can see. So integration by parts, as always. Right. X negative 1 0 secant x tangent x. This is secant. You actually didn't have to rate this, but just for the sake for you guys, I'm just going to write it so that you guys understand my mindset of what I'm thinking. Okay? And then you could just go ahead and dive into the answer like this. And this is the answer. Let's see, is that what they put? Yep! Alright. Awesome. Next integral. Ugh! What the hell is this? Okay. Let you equal this immediately. Okay. So let me first write this out because I don't think I can memorize that. We had like 5. No. It was 2 times. Was it 2? X plus what? What was it? X plus 2. Oh no, it was 5. Yeah, as you can see, I have to write all this down because I don't memorize it. X plus 2. Okay, wait, let me just make sure it's correct. Okay. Okay, so I noticed that we have 9 over 5 with x plus 2. Oh my god. That's nasty. So x plus 2, we have 1 minus, okay, so 4/5. So we get 5/4 times 9 over 5 of x plus 2 of, wait, what am I doing? No, 9/5, then the other, yeah, okay. So this is, your answer should be this. X plus 2 to the power of 9/5. Is that what that is? Yes, it is. Okay. I almost messed up there. Okay. This is a good example of like what happens if you rush. If you rush too much, you become inaccurate and you start to think like me. Okay? Do not become like me. Okay? Be accurate. Be accurate. Don't over rush. Okay? Know where to be cautious with. Okay? Alright. Because your opponent can rush, but then they'll get like a wrong answer and you can eliminate them. That's like a great chance to eliminate your opponent. Okay. Next one. Oh, I thought I skipped for a second. Fractional parts. Okay, so whenever you see this, so fractional parts, whenever you see a function where everything is all in terms of fractional parts, okay, I want you to understand that fractional parts is a periodic function. Like sine of x and cosine of x, like these are periodic functions, right? So is fractional parts. Okay, I need you to understand fractional parts, they're periodic functions. And they are periodic at every, what, their period is like 1. So what you can do is whenever you have a periodic function where f of x is periodic at t, this is the periodic rule. Okay, if a function is periodic at t, okay, then it's from 0 to t, and then you can multiply n like that. Okay, so in this case, fractional parts are periodic at 1. So from 0 to 4, and we have like this. I believe that's what we have, right? Yes. Okay, so this is periodic at 1. So we're going to get 4 times 1, that's from 0 to 1, because it's periodic at 1. And now, this is what we have. And what I really love about this is that the fractional part of x, okay, this is x minus floor of x. What is the floor of x between 0 and 1? 0. So this is equal to 4 times from integral from 0 to 1, x4. Okay? So this is easy. So now it's just 4/5. So the answer should be 4/5. Yeah! Okay. So do not forget that. Okay, if all the functions in terms of fractional parts, you can utilize the periodic rule. Okay, it's so much faster that way. All right. Give me an integral. Force u sub. Alright. I got no problems with that. Let u x plus 2 plus 1. Is that what you did? Oh no, that was nowhere. That was nowhere close. I have bad memory, as you can see. Square root of x plus 2. Okay, that's correct, right? Yes, it is. Okay, force u sub time. U square minus 2, and then this is equal to square root of x, and then dx is 2 times u squared minus 2, and then we get 2u du, and so what we have from u du, we get like 4 u cubed minus 2u. Oh, that's actually kind of nice, because now we have like this and this cancels out, and so we actually just have u squared minus 2. Okay, wow. So in that case we have like u cubed 2u, and so now our answer is 4/3 of u. U is equal to square root of x plus 2 is now 3/2, and then minus 8 of u, which is like this. So I guess this is our answer. Let's see what they say. That is exactly what we have. Yes. Alright, awesome. Force u sub for the win. Okay. Next. Oh, okay. x9, ln of x. This one, I've done this so many times that I kind of get a feel of it. I don't know why I did that. So, but pretty much what we have is ln of x minus x over 100. So I think this is my answer. This I would conclude. I conclude this is my answer. That's exactly what we got, and we got it right. Let's go. Okay. A lot of common integrals, like once you do it a lot, like so many times, you tend to get a sense or like a feel of the answer. So that will happen when you practice integration B. Okay. Oh, it's one of these again. Alright, here we go. So, we have from 0 to 9. 1 plus, this is 9. dx, let u equals square root of x. So, now we have 2u squared of 9 plus u squared. This is now so 3 plus 9, so minus 9. So we get something like u minus 3 inverse tangent of u over 3 from 0 to 3. And then we know 0 is going to be 0. So 2, we get 3 minus 3 pi over 4, right? So answer is just going to be 6 minus 3 pi over 2. So 6 over 4, yeah. 6 minus 3 pi over 2. I hope I didn't mess that up. 6 minus 3 pi over 2. Let's see what we got. Yeah! Alright. Surprisingly, my accuracy is getting a lot better. Surprisingly, my accuracy is getting a lot better. For unknown reason. Okay. Usually when I rush, I'm not quite accurate. As you can see from most of my videos. This looks, just looking at this. This looks like ex plus 1 squared at the bottom, right? So if you can do that and notice that, you could just, you don't, instead of rewriting it, you can just rewrite it in your way. Okay. However, oh. Well, another good reason why you should not rush like me. So, oh wait, There's a 2 here. Wait, no. I'm sorry. Wait, e to the x squared. Oh no, it's this 2. Oh, you mother. It's this 2. I didn't see this 2. If you have dyslexia, I really apologize. Some integration bee problem writers are, they're very evil. So let's actually do this properly. I was being extremely lazy, so I apologize. But this is what we actually have. Okay, so here again, we would e to the x dx. So we would have e to 2x plus 2e to the x plus 2. So what we have is when we let u equal e to the x, we get du of u plus 1 squared plus 1. And now this is equal to inverse tangent of e to the x plus 1, which is what they have. Okay? So, completing the square. Okay? Do not be like me and rush everything. Please be very careful. Okay? I did not see this 2 here. Okay? My rushiness hallucinated me. Okay? So, practice your accuracy. Don't be like me. Okay. Ooh! Oh! Now we're getting spicy. Okay. So, from 0 to infinity, we have 1 plus x squared, and it was like what? 1 plus 2024 ln of x? 1 plus 2024 ln of x. Now we're really getting spicy. This is technically ninja sub by using inversion, right? So what we're gonna have is it's the same thing here, but now we have 1 plus 2024 minus ln x, right? And then in which you can you can adhesively conjoin these two integrals, and they're going to cancel out, and we're going to end up like this. And so the answer is going to be pi over 4. I think. I hope I did that correctly. Yeah. So that should come out as pi over 4. I'd be so mad if that's not pi over 4. Okay. Good. Alright. Next. What is this? Why would they give such an integral? Why would they give such an integral? Why? Is it x plus 1 x plus 2? It was x plus 1. Okay. So whenever you see something like this, for speed integration's sakes, I'd say let u equal square root. And the reason is because I don't like dealing with fractional exponents. So for me to escape fractional exponents, I just use up the whole entire square root instead. Okay? So that I don't have to deal with fractional exponents, especially with like things like this. Now it's just from 0 to 1. Okay? Now I can go ahead, this is u with 2u squared, and then x is equal to u squared minus 1 du. And now this is a lot easier to deal with. Now it's just this. u4 minus u squared. This is like, what, 1/5 minus 1/3. And so I would leave my answer like this, honestly. But knowing them, they probably want this. I think this is what they answer. 3, 5, negative 2, negative 4 over 15. Did I do this correctly? I hope I did, because it's a negative number. Negative 4 over... If it's positive, I'd be so mad. Okay, there you go. Negative 4 over 15. Yeah, so things like this, it's faster to let u equal the square root with it, so that you don't have to deal with fractional exponents when you do power rule. Okay? It's just mentally faster. Okay, I already can see that you let u equal x4. So you can, so it should be like 2 inverse tangent of x4 plus c. Yeah, I can already do that in my head. Alright. Ooh! What is this? X cubed minus 1? Now it's just getting real easy here. So it's 1/3 ln of x cubed minus 1. Yep. Too easy. Oh, what is this? Y'all know what to do. Loophole log. Wait, let me. So 0 to e. So we have 0 to e. X ln of x negative 1. Oh, it's this, which is equal to e. So we should have e squared, right? Yeah. Yeah, if you do loophole log, you let x, right? And this is going to cancel out as e, because ln of x over ln of x, they cancel out. Okay, awesome. Here, sine 2x. Remember the derivative of sine square? Right? It's sine 2x. So, this is actually, we could actually u sub the entire thing if you think about it. Not u sub the entire thing, I'm sorry. The entire denominator. Pi over 4. So pi over 4, we have sine 2x, and we have 1 plus sine square of x dx. I would let u equal 1 plus 2 sine square x, then du is going to equal to 2 sine 2x. Okay, this is sine square. So we're u subbing the entire denominator, and we get this. So now we have 1/2 of u du. It's just a lot faster. It's just so much faster. So now we have 1 and pi over 4. We get 1 plus root 2. I think that's what it is, right? Oh no, no it's not. That's squared. I'm sorry. So that's 2. That's 2. So half of ln of 2. So ln of 2 over 2 would be our answer. ln of 2 over 2? Is it ln of 2 over 2? Yes it is. There you go. Okay, be extremely careful. That's not sine, that's sine square. Okay? Do not rush. Do not rush. Be careful of rushing. Alright. That is secant, oh, okay, so 2 ln of secant x. Let u equal ln of secant x, then du is just going to equal to tangent of x dx. Yes. So, we pretty much have 2u, so u square, so ln square of secant of x plus c. Or that too. That's also correct. Okay. Alright. Oh, of course. Of course. Who wouldn't give such an integral like this? Here, we're gonna do this we're gonna integrate this like a boss. You wanna know how to integrate this like a champ? I'll show you. Y'all know what I'm gonna do. Y'all already know what we're gonna do. Okay? We're just gonna let this all out, express it, right? What do we do here? We're going to do backhanded symmetry and use Glasser's master theorem. That's right. So we're going to go like this. Then we're going to go like x minus 1 over x squared. So I did minus 2 plus 4. Ooh, would you look at that? Okay. So now, with backhanded symmetry and then with Glasser's master theorem, okay, we end up getting x squared plus 4. This is now 1/2 of inverse tangent of x over 2, 0 to infinity. It's pi over 2, so we get pi over 4 as our answer. So I hope I didn't get anything incorrect. Hopefully I didn't leave anything behind. But let's see, minus 2 plus, yeah, I think it should be pi over 4. Let's see if I get pi over 4. Yeah! Alright, awesome. Okay. Next, sine cube cosine of x. Alright, so we're going to abbreviate this. So we have integral of sine cube over square root of cosine of x. How can we play with this? So we notice that we can go like this. If you can see this, I'd rather just go ahead and just dive into let u equal cosine of x. Okay. Or I could take that negative and let u square minus this. And so now we can go ahead and dive in. Okay, this is 2 minus 1 half, 3 halves. 2 minus 1 half is... Okay, I just want to make sure I'm correct. I can leave this because I'm comfortable. So u 5 halves, 2 fifths, minus square root of this. Okay, so I should have my answer would be cosine 5 over 2x minus the square root of cosine of x plus c. Okay? Is that what they have? Yep, there we go. Okay? Awesome. Of course. What did I tell you? Okay, a reoccurring integrals. Caveman, let's go. Let's go. Caveman trick. Here we go. From 1 to 10th root. 10th root of 2. dx of x, x10 plus 1. Right? That's what we got here. Alrighty, you know what to do. Caveman trick we go. Alright. We have x, x10, then we do 1 plus x to the power negative 9. Oh god. Yeah, I'm not simplifying this. This is disgusting. How do they write it? What? 4/3? 1 over 1 over 10. Hold on. That's not good. I messed up somewhere then. Where do they get 1 over 10? Hold on. X to the... Oh! No! I came in the wrong... No! I came in the wrong integral! No! I came in the wrong integral! Oh, no! This should be 11, 1 plus x to the... Oh, okay. Oh my god, I went too fast and I thought about the... Okay. Well, there you go. Please work on your accuracy. Don't be like me. Do not be like me. Okay. I see my mistake now. I'm sad. I'm very sad. Okay. That's an odd function. So we can split this. So what we have, take away my sad integral, from 0 to pi over 2. I'm just going to use symmetry because it's an even function. Then we get cosine of 2 minus cosine squared, right? That's exactly what we have. Yes. So here we can go like, we can utilize 1 plus 1 minus sine squared, which is sine squared here. Okay? In which this is equal from 0 to 1 du 1 plus u squared. And we see that we have pi over 4. Pi over 2. So our answer should be pi over 2. Yeah! Okay. This is just an odd function. So we just use symmetry on that. Okay. Symmetry! Use symmetry. Alright. What is this? This looks simple. After that other integral. Cotangent of x minus 2 cosine of x. That's pretty much what we have. Because that's sine 2x. Yeah. So then our answer is just ln of sine of x minus 2 sine of x plus c. Yep. There we go. Alright. Of course, another reoccurring integral. Okay. Already, this is like 2 sine of u. So our answer would be like square root of x, negative 2 cosine of square root of x. Yep, there we go. very, very reoccurring. You could probably do it in your head too. But I'm just careful now. I'm very careful after that caveman integral. Okay. Oh, this is inverse tangent of x plus 1 over x. I can already see this. This one I can already see. So this is pi. Right, if you substitute 0 for x plus 1 over x. Oh no, no. 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 Huh. Is it not pi? I would have guessed pi. But, can I guess? I'm gonna guess pi. I'm lazy. What? Huh? Excuse me? What? Okay, well, my indefinite answer was correct. But, oh my god. What happened to the bounds? Does it not? I'm assuming it diverges. I'm guessing. If you plug in 0, you get infinity. I'm sorry, no, the left side of 0. Wait, so if you think of the left side of 0, oh no, it is infinity. Left side, no, not left side. Right side of 0. We go to the right side of 0. It goes infinity. So pi over 2. And then plug in infinity though, you get pi over 2. Does that just equal to 0? I think they didn't mean to put the bounds there. I think that was an accident. No, it does equal to 0. Okay. So it does equal to 0. So the actual answer should be 0. Which now I think about it, it does make a lot of sense. But I guess they meant to put it as indefinite integral. Alright, it's okay. It's okay. Next. Of course. This is, let's see, if you divide everything by x, you get 1 minus 1 over x, and you get x minus, yeah, so you get ln, your answer should be ln of x minus ln of x. ln of x minus ln of x. Yep. Oh, why would you? Oh, I'm sorry. After this, you decide to throw this. What is wrong with you? Oh. What is wrong with you? Why would you? Why? Why would you? Oh, is it the other way around? It's the other way around. Okay. So, 1 minus x squared dx. You guys want to know how to solve this? Geometric series. We're gonna, let's see, this is equal. Well, I'm sorry. No. That's too complicated. We'll simplify it much. When you're speed integrating, try to simplify as much. Don't overcomplicate things. So we have x to the power of 2n. Right. So what we have is we have x to 2n plus 1 ln of x. Okay. So add ln of x, 2n plus 1 here, 2n plus 2 over 2n plus 2 here. Okay. Plugging in 1 and 0, this is just going to be 0, this whole thing. So what we actually end up with is we get this from 0 to 1, and we get like x 2n plus 1, 2n plus 2. We end up getting the series. It's negative. So we're going to get 2n plus 2 squared. Looks like it. I'm just going to rewrite it like this. So we have negative 1/4 of a Gaussian integral, technically. So negative 1/4 pi squared over 6. So our answer is negative pi squared over 24. I swear, if I mess up a negative somewhere, hold on. Let me retract my thinking. Okay. So I hope, yeah, because that negative, when you do integration by parts, you get a negative. So yeah, I'd say negative pi squared over 24 would be my answer. Yeah, there we go. Alright. Geometric series for the win. Okay. I'm sorry, that was easy? Hold on. All of this was easy. We've just reached medium. Excuse you, what? This was easy? Huh? You call this? Okay. Alright, Caltech. I see you. Okay. Wow. Alright, let's get our let's get our enhancement potion on and dive through these so-called medium level integrals. Alright, let's go. Oh my god. Is it x to the power of x squared plus c? Let me double check. I'm gonna double check before I guess. So x squared, they have this. So e to the ln x squared plus 1. And so their derivative should look like this. And then x squared should be x. Right? Oh, okay, yeah, I was right. So it is x squared. So x to the power of x squared plus c. Yeah, I was right. Well, there you go. Okay. Next. Oh, why? Why would you give this integral? Oh, okay. Well, to speed integrate this, I'm sorry. I'm gagging a little bit because why would they throw this? It's not even just hard, it's just tedious. Okay. Well, I'm gonna cheat by letting u equal inverse tangent of x. You can't do this in an actual calculus class. Your teacher will downgrade you on this because this is actually they don't accept this because this is illegal in calculus teachers' terms. But I would allow my students to do this because it's cool. Now, tangent. Now notice that tangent of u is equal to x. We already have the x squared plus 1 taken out, so we just left with the square root of x squared plus 1. And since x is equal to tangent, we end up with secant of u. And this is why I am disgusted, because look what we have. Okay. Thankfully, I memorized this. Oh, that's pi of 4. The way to see this is half times this, and then e to the u, you get cosine plus s plus cosine minus s. So pretty much it's reverse product rule. Does that make sense? So that's how I kind of memorize this. Oh, okay, this is e to the u sine, and then plus cosine. Okay, so that's just my tip on that. That's how I mentally memorize this. So now what we have here is pi over 4. This is 1 over root 2, 1 over root 2 of e to the pi over 4 minus 0, 1, 1, half? Is that correct? I really hope that's correct. I really hope that's correct. Minus a half. Okay. Yeah, okay, I got it. Woo! Alright, awesome. Okay, next. MIT integration bee. This is 0, isn't it? Is it 0? It is 0. They my god. Sometimes a lot of integration bees will reuse integrals from MIT integration bee. So it is very important that you practice with MIT integration bee problems, because a lot of integration bees, they'll just reuse it. Okay, but this is equal to 0 by symmetry. If you split this up, right, by using the sign addition or subtraction law, you get sine, cosine, cosine, sine. When you do that, one side is the u sub, the other side is periodicity or symmetry. So sine of x, cosine of x minus cosine sine of x. Yeah, the other side would just be symmetry-ish. Yeah, periodic symmetry technically. The other term would be u sub, and then also symmetry. So this whole answer would be 0. Okay. Oh, damn. Huh. If I let substitution, if I let u equal negative x, and then we get pi over 2, but that's only because we added it together. So pi over 4, and then after pi over 4, we get square root. So pi square root of pi over 4. Yep. See, and so this is what I mean, like practice. You get a sense of ninja substitution and stuff, and you could easily mentally solve it. And there you go. Okay. You could probably solve it faster than me. My brain is just being lazy-minded. Okay. Oh god. Here we go. All right, let's go. We're gonna sum it up. We're summing it. They consider this medium. They call this medium. The fact that they call this medium. Oh my god. Oh, I'm sorry. Wait. I didn't see. Is it 0? It is 0. Huh. Interesting. Fractional parts. Okay. Oh god, here we go. So we're gonna let n equal to 0, and n plus 1, x minus n plus 1, and then we have n plus 2, and this is equal, let u equal x minus n, we get this from 0 to 1, 0 of n plus 1, n plus 2, we end up with n plus 2, n plus 2 square. So what we have is the sum of n plus 2 square. That's like 2 square, and then plus 3 square plus 4 square. Okay, so it's the Gaussian. This, right? So this is pretty much pi square over 6 minus 1. Okay? So I believe that's what that is. So pi square over 6 minus 1 would be my answer. There you go. Alright. You guys probably could solve that faster than me on that one as well. I'm just being lazy-minded. Okay. Oh my god. Taylor series. Well, it's not really Taylor series, it's geometric series. But x. Here we go. Okay, we got this. We got this here. Let me double check that I'm doing this correctly. Yes, I am. Okay. We're going to use n equals to 1 of e to the negative nx. This is going to equal to 1 minus e to the negative x. That's minus, right? Yeah. So then we also have e to the negative x as well, right? If this was plus, you need to be very careful, because if this was plus, then you have like this, but you have to be extremely careful that, oh, if you start with 1, make sure you have a negative sign. Okay, but for now, thankfully, this is just this. So we have x e to the negative nx. Okay, it's going to go down 1 over n squared, right? If we plug in 0, infinity, this part is going to be 0, so we're going to be left off with this. And so we have e to the negative n over n squared. That's negative from infinity. So we end up with 1 over n squared. So pi squared over 6 is our answer. Oh, yeah, okay. I was like, wait, is n equal to... Okay, n is equal to 1, yeah. So I guess my answer here is pi squared over 6. Wow, pi squared over 6 minus 1 to pi squared over 6. Crazy. Definitely not suspicious at all. Okay. Let's go. Oh no, please! No! I don't want to do this! Come on! Let's... Oh my god. Oh no. I don't want to... You're not going to make me graph. I'm not going to graph. I'm not going to graph. You will not let me... You will not make me graph. Screw you. I'm going to go like this. 1 minus c squared with c. I'd rather do quadratic formula than graph. C minus 1. I think that's correct. Okay. Then cosine of x is equal to negative 1 plus or minus square root of b minus 4ac all over 2. Is this a golden ratio? Not exactly. Oh, it is! Oh, it is! Okay. So this is like... So you could equal to this or 1 over phi. Huh. That's interesting. Okay. Well, you see, that's disgusting because that's nowhere to... Oh my god. Why would you do this? Why? Why would you sine of x cotangent? Why would you bring golden ratio into this? Okay, well, we're not going to use this because our bound goes from 0 to pi over 2. So, oh wait, no, because our x is equal to inverse cosine. Oh no, you bastard! You're gonna let me split to here? What is wrong with you people trying to mix Math Olympiad problems into integration B? I swear to God, this is... Okay, first of all, this is equal to... What is it? Real phi squared is equal to 1 plus phi. So phi is equal to 1 over phi plus 1. So this is equal to phi minus 1. So we have this. Oh, but then we have this is also equal to inverse cosine of phi. Oh my god. Oh wait! If you think about it, cosine of x can never be... Oh... Yeah! So this can never be true. Oh, you sneaky. Okay. So this is... So we only have to split it to here. But the thing is... We don't know... You know what? I'm lazy. I'm just gonna go like that. Screw it. At this point, this is horrible. This is torture to the students. I'm so sorry to whoever had this. If you think about it graphically, Oh no, don't think about it graphically. What am I doing? Pi over 4. Wait, but what is... we don't even know what this goes to. Like, is this less than pi over 4 or equal to pi over... or, not equal. Okay, a great way to see this is cosine of x. If x is equal to pi over 4, then this would have been 1 over root 2, right? But we have 1 over phi. So, if you think about it, 1 over root 2 and phi, 1 over root 2, go in ratio. This is 1.4, 1. Okay, so they are greater. Okay, so if that's the case, then this is greater than 1 over phi. So it seems that so pi over 4 would be bigger than inverse cosine of 1 over phi. Okay, so I think that's where we're going. Okay, so that means, so if we plug in pi over 4 here, so pi over 4 is here. So pi over 4 is at this interval here. So if we plug in pi over 4, this is 1 over root 2. The cotangent of pi over 4 is equal to 1. This is sine of pi over 4 is equal to 1 over root 2. So obviously cotangent of pi over 4 is bigger. So did it ask for max or min? It wants the min. So because the min over here is pi over 2, sine of pi over 4 is smaller, this is sine of x, this is cotangent of x. Okay. So now we have that this is from 0. You know, just for that, I'm gonna say it's the other way around. just for that. I'm gonna say it's the other way around. I think they meant to put max, I don't know. But just for that, I think it's the, because that would have diverged. Is this all negative? Goddamn. Oh no, this is positive. I'm sorry. So is this my answer? Is the golden ratio actually in there? Yes, it is. I don't know if that's correct. I don't know if I got it right. Negative half. I did not simplify my answer. 1 minus 1 over phi. 1 minus 1 over phi. Negative 1. Would have had negative 1. So 2. I don't think I got it right. That doesn't seem... Yeah, I think I got it wrong. But the reason why I decided to switch... Maybe I was right in the first place, where it actually is... I was just being a little immature. Maybe it was actually... Like, this was actually correct. Based on these, for sure, this has to be correct. But it was nasty because, like, this diverges. Right? But then I think about it, no. Because then this is continuous. Yeah, so this doesn't make any sense. Yeah, so it would definitely be the other way around. I don't know. This is horrible. It's horrid. It's awful. This is not something I would put in integration B. This is like a math Olympiad stuff. Like, why would you do this? Why would you, like, please, no more integrating math Olympiad problems into integrals. It's not fun. Oh, and that was it. That was the last one. That's evil. Well, okay, at least they know what's the hardest one. Like, this was definitely the hardest one. But that is it. Well, there you go. Holy hell. Woo! That was fun. Alright, well, that's it. That's pretty much it. How many integrals have I missed? A lot. Probably like 5 integrals I missed. I missed 5 integrals. For sure. But yeah, there you go. Those are the finals integrals from Caltech. Alright. Thank you guys so much for watching. Sorry this is a long video, but thanks for staying with me. And yeah, hope you guys enjoyed. I'll see you guys in the next video. See ya.